So how can we recreate this earthquake cycle stick-slip behaviour at home? Well, to do that I've got a simple experiment which I'm going to show you. What I've got is I've got a brick here and I've put a nail into the end of it, and I've got a piece of elastic that's attached to that nail. What I also have is a wooden board. You can see here this is wood, and there's a piece of sandpaper attached to the top of the board, which I'm going to use in the second part of the experiment. So what I'm going to do is I'm going to place the brick onto the wooden part of the board, and I'm going to use the elastic to try and slowly pull the brick from right to left across the board. So how does this relate to our model of the earthquake cycle? Well, you can imagine that me pulling on the elastic is equivalent to the relative plate motion between the two plates, which is going to drive the movement along this fault. We can think of the wooden board as being one of the tectonic plates, and the brick as being the other tectonic plate, and the contact point between them is the fault plane. And as we said, the friction along that fault plane is going to be what causes the stick behaviour. So in this case, that'll be the friction between the brick and the wooden board. So what we would expect to see is that if I pull on this elastic, there's going to be strain building up in the elastic, and that's going to build up until the amount of force that I put on overcomes the friction between the wood and the brick. When that happens, the brick should move and it should slip, and that slip movement will be the stress release that's formed during this earthquake. Okay, so let's have a go and see if it works. I'm going to try and pull on the elastic as kind of slowly and continuously as I can to best represent tectonic plate motion. Okay, so you can see I'm pulling on it. Nothing has happened yet, the brick hasn't moved. And then suddenly the brick moves in our earthquake event, it's got stuck again, and then it moves again. So you can see that despite the fact that I'm pulling on the elastic continuously, the brick does not just move across the board in one smooth movement. It gets stuck and it slips, and that's the exact same behaviour that we see in faults, and that's how we form earthquakes. So let's try again with the sandpaper part of the board. So I'll move the brick here, and as you can imagine, the sandpaper is a lot rougher than the wood, and what I've done therefore is increase the friction of the fault plane. So what we should expect is that it takes a lot more stress build up before the brick will slip. So let's try that and see what happens. Hope I don't break my elastic. So you can see the brick is really not moving, it's pretty stuck. And there we go. You can see we're stuck again. Yeah, I'm scared of breaking the elastic, so I'm going to stop. But what you can see is that the change in friction makes a huge impact on the motion along this fault. So we need a lot more stress to build up before we cause an earthquake. So you might expect that in this case, the earthquakes will occur at much longer timescales than on our wood example.